Oh, welcome back everyone. I've just got another couple of bits of origami paper here. So let's have a look at this side. Let's get the nice pattern side here. We know how to work out the area of that shape, and we know if we've got a triangle here, we know how to work out the area of that shape. We've done that as separate skills. Now, for example, what happens if I join these guys together and this is my shape? All right. How do I work out the area of this? It's really simple. In your mind, just imagine them as two separate shapes and put a plus sign between them. Big fat plus sign. So you work out the area of this, and your mind works in your mind. We work out the area of that, and the big plus sign in the middle tells you that we're going to add the areas together, and this is our the area of our final shape. So they're the kinds of things we want to look at. So that's adding things together. What happens if we have a shape like this where I've come in there with a pair of scissors and I've cut a little triangle out of the corner, but that should allow us to work out what the original shape was and then subtract the little triangle that I cut off the end here. So in that case, what I would be drawing is say a square, subtract a triangle, and I'd be putting my measurements on that. And I'll show you that behind the light board. And the biggest mistakes I see is that people will work out those shapes separately, and then they'll either forget to add them together to create the composite shape that they started with, or they'll forget to subtract something away because the shape might have a void in it. For example, a void, when I'm talking about a void, if we cut, for example, a square out of the middle of this shape here, we would have to subtract that away as well. So they're my big tips. Anything you got here, you can, with your mind, with a bit of practice, either pull them apart or look at the negative and see what's missing and think about what that shape should be, and that will help you with your calculations. All right. Okay, in this video, we're talking about composite shapes, and what we need to know is there one or more basic shapes. And the good news for us is that all the shapes that we're dealing with so far are made with a straight edge. Okay, so it's really a case of looking and seeing what basic shapes have either been added together or one has been subtracted away from the other in to create a void or change the shape ever so slightly. So what I'm going to encourage you to do, if you see something that looks like this, say a square with a triangle on the end of it, I want you, don't copy that out of the textbook, but instead draw something like this. Separate out the shapes, put a big plus sign next to it, and then draw your shape separately. So we've got a square here. So if we're working out the area of these composite shapes, we might write A equals, that's going to be L squared plus a half base height, for example, for our triangle. And do the maths underneath there, and you'll arrive at your answer. What I find is most people do the work on each separate shape and then forget to add them together. So making that plus sign big in between is helps you come back to the task and remembering what you need to do at the end after you've done all the separate little steps. For the same reason, when you've got a shape that looks like this, for example, and that has been cut away, we're going to perhaps do this. We're going to write in our books the entire rectangle here and put the dimensions on that, and then we're going to subtract. So a nice big subtract sign, and we've got a triangle there in the corner that we need to work out the dimensions for, but subtract that away would be the moves that I would do. And underneath that drawing, you'd set out your maths and lay it out. So visually it's easy to look back and check if and when you've made a mistake somewhere. So I've just got a couple of examples here to run through with you, and I'm just going to draw them and do my best here to write down the measurements. I'm not sure whether that's going to disappear off the top of the page. I'm not sure, but it's a 12 meters up the top. I might write it on the inside of the shape to help us out here. So what am I looking at here? I'm looking at, I've got different ways I could play this, but let's do area equals a rectangle whose dimensions are going to be 5 and 9. So that's 45 plus I'm going to add a triangle here whose dimensions will be the base. 12 minus 9 is 3 meters, and the perpendicular height here is 5 meters. So we're going to do a half times 5 times 3, so a half of 15. I'm going to write that as 15 over 2, and then finally crunch my numbers, and that's going to be the equivalent of 7.5. All right. So that is going to be 52.5. I think we're working in meters squared. Okay, so there's the area of my composite shape, and I'm running out of room like always. I'm just going to take this diagram away and put another one in its place, something a little bit more complicated, because hopefully you'll see through this one the value of doing this work here. And what do we got? Those lengths are 4 meters perhaps, and this guy up here is 8 meters, and this one over here is 5 meters. There's some things we need to work out, but we'll get there. And so what am I looking at here? How do I want to do this? And so you've got to make some decisions. I'm wondering if I make, if that's 4 meters, that's 4, and that's 4, and that's 4. So this entire length here is 12 meters. I'm wondering if I make a big rectangle here, and it's 8 meters by 12, and 8 times 12 is 96. So 96 meters squared. And now I'm going to subtract off a bunch of stuff. I've got in the middle here, I've got a square, and that square's dimensions is 4 meters. So I'm subtracting 16 off there, 16 meters squared off there straight away. And because I turn this into a square, I need to subtract out this area here. So I'm going to do the work here. What's that? I'm at 80 meters squared, and I've got a little bit more. 80 subtract a half times 12 times 3. So that's going to be the same as 6 times 3, which is 18. So I'm at 80 subtract 18, and that leaves me at 62 meters squared. For the original shape, I've made a mess of it now, and it's hard to see what we had when we started with, but I'm fairly confident that thinking flexibly about this has led me to get the answer correct here, where if I quickly redraw the original shape, we can see what we started with, and that might be a good idea. And that was 8 meters. Those lengths were all the same. That was 5 meters, and these were 4 meters. So what I'm saying here is that the area of this shape, this composite shape, is equal to 62 meters squared. And you can see how I thought about it and how I went about it. So that's the kind of work I want you to do, and that's how I want you to set it out and keep track of things. The big trap here is that we move too slowly because we try to do too much in our head. And the other trap is that doing a lot of things in our head will also lead to making mistakes. So here's a way to set it out, and you can double check your work along the way. So thank you.